Over time, a sample of a radioactive isotope will lose its mass. The length of time for the sample to lose half of its mass is called the half-life of the isotope. Carbon-14 is a radioactive isotope commonly used to date archaeological finds. It has a half-life of 5,730 years. If the initial mass of a carbon-14 sample is 88 grams, the formula used to find the mass remaining as time passes is given by A equals 88 times 1/2 raised to the t over 5,730. In this formula, A is the future mass, and t is the time in years since the mass of the sample was measured. In part A, we are asked to find the mass of carbon-14 in 2,000 years. Start with the given formula, A equals 88 times 1/2 raised to the t over 5,730. Plug in 2,000 for the elapsed time. (2,000) divided by 5,730 gives us 0.3490 continuing. Using a calculator, we get approximately 69.09 for our result. In 2,000 years, the sample will have a mass of approximately 69 grams. In part B, what will be the mass of the carbon-14 sample in 5,730 years? Plug in 5,730 for the elapsed time. (5,730) divided by 5,730 evaluates to 1. This gives us a result of 44. In 5,730 years, the sample will have a mass of approximately 44 grams. This is half of the original mass. In part C, if the mass of the sample is measured 10,000 years in the future, what percentage of the original mass remains? Plug in 10,000 for the elapsed time. (10,000 over 5,730 becomes 1.7452 continuing. The result is approximately 26.25. We can get the percent remaining by dividing the mass in 10,000 years by the mass today. This is 26.25 divided by 88, which gives us 30%. So in 10,000 years, only 30% of the carbon-14 will remain.